Hello students, today we are going to discuss about the Milne-Thomson method, an example with the Milne-Thomson method and how to find out the analytic function by using the Milne-Thomson method while real and imaginary part is given in a question. This is the required formula. When a real part of analytic function is given, then the analytic function fz is equal to this, where partial differentiation of function u with respect to x and x is replaced by z and y is replaced by 0. Similarly, partial differentiation of function u with respect to y and again x is replaced by z and y is replaced by 0. If a imaginary part v is given in a function, then the analytic function formula is fz is equal to this value, where similarly we have to partially differentiate v with respect to y and replace x by z, replace y by 0, and partial differentiation of v with respect to x and replace x by z and replace y by 0. Now the example is, if u, a real part, is equal to e to the power x cos y of analytic function, then find out the analytic function fz by using Milne-Thomson method. U is given, that means we have to find out the value of fz, and fz is equal to integration of u x z0 dz minus iota integration uy z0 dz. So where u is given, we have to find out the partial differentiation of u with respect to x. Del u by del x is equal to partial differentiation with respect to x is e to the power x and cos y. Then del u by del y is equal to e to the power x is constant. Differentiation of cos is minus sin y. That means e to the power x sin y. Now the function of fz will be equal to integration of e to the power x, partial differentiation of e to the power x, and replace x with z and y with 0. So e to the power z and cos 0 dz minus integration I cap partial differentiation of u with respect to y, this value, minus, and e to the power z and sin 0 dz. Sin 0 is equal to 0, cos 0 is 1, so we get fz is equal to integration e to the power z dz minus plus and multiplication of 0, that means 0, that is e to the power z. Integration with respect to z is e to the power z plus an arbitrary constant. Then the solution for the given problem is fz is equal to e to the power z plus c. Similarly, we will do for the imaginary part. If the imaginary part v is given, then we will use the formula for fz for the value of v and solve it. Now this is the question which you have to do yourself, where the imaginary part is given, v is given. You have to find out the analytic function by using Milne-Thomson method. Thank you. For any doubt and any query, please feel free to contact me on this number.